Hello everyone, welcome back to our Artificial Intelligence and Machine Learning course. In today's lecture, we are going to study one of the most important uninformed search algorithm in AI called breadth first search, commonly known as BFS. This algorithm is widely used in robotics, path planning, GPS navigation, computer networks, social media analysis, and many other AI applications. By the end of this lecture, you will be able to understand what is BFS, how BFS works, advantages and disadvantages, and step-by-step example, and time and space complexity, real-world applications. Okay, let's begin. Breadth first search, one of the searching algorithm in uninformed search strategy. It is one of the simplest and most popular search algorithms used in artificial intelligence. The word breadth means moving level by level. Instead of moving deep into the one branch, BFS first explores all the nodes at the current level before moving to the next level. Suppose you are standing at the entrance of the building. Before going upstairs, you first inspect every room on the ground floor. Only after completing the ground floor do you move to the first floor. That is exactly how breadth first search works. It starts from the root node, visit every neighboring nodes, and then moves to the next level. Because of this systematic approach, BFS always find the shortest path when all edge costs are equal. Now let us discuss the important features of breadth first search. The first feature is that BFS is a graph transversal algorithm. It can be used to search both trees and graphs. The second feature is the BFS uses a queue. We have queue models, first in first out and last in first out. So many queues are available. In this search, we are using FIFO principle. This means the node that enters first will leave first. For example, suppose 5 students standing in a queue, the student who come first will be served first. Similarly, the node entered or inserted first into the queue, it will be expanded first. This FIFO property helps BFS explore nodes level by level. Some advantages and disadvantages are BFS is available. Let's discuss the advantages first. The biggest advantage of BFS is the complete. It means if a solution exists, BFS will definitely find it. Okay. Another important advantage is that BFS always return the shortest path when every edge has the same cost. Because of this property, BFS will be used widely in navigation system. Now let us see the drawbacks of this system search. Since BFS stores every node of each level in the memory, so it requires a large amount of memory. If the search tree becomes very large, memory consumption also becomes very high. Therefore, BFS is not suitable for very large search spaces, complex problems. Now let us understand BFS using a simple example. In this problem, A is the start node or initial node, G is the goal node, Suppose node A is the starting node and node G is the goal node. Initially, the queue contains only one node, that is A. And now we will remove A from the queue. And next search is its neighboring nodes are B and C and D. A consists B, C, D nodes. We visit all three nodes and place them into the queue. Now become queue is B, C, D. Okay. Next, after visiting B, C, D, BFS visits every neighboring nodes before going to deeper. Okay, next, remove node B because B does not have any unvisited neighbors. So the queue becomes CD. Okay, now next, remove C. Again, there are no new nodes to visit. Q becomes D. Okay, next, remove D, and D has two child nodes, that is E and F. Both are inserted into the queues. Now the queue becomes E and F. Now finally, visitor nodes are A, B, C, D, E, F. And next, we have to remove E. E is connected to F. Since F is already waiting inside the queue, so we don't insert it again. This avoids duplicate processing. So now Q becomes F. Okay. Next step, we are going to remove F. F has one child, that is G. Insert G into the queue. Now Q becomes G. Finally, we are going to remove G. Since G is our goal node, now going to search is stopped. Finally, visiting order is A. First visit A and B and C and D, E, F, G. This clearly shows that breadth first search expose nodes level by level. Okay, thank you.